Hi everyone, my name is Max. I'm an application engineer with AGI, and today I'm going to talk about the new data rate capability for chains in STK 13. For those unfamiliar with the chain object in STK, the chain object allows you to extend the access analysis capabilities of STK. By defining a start object and end object in a set of object connection pairs, STK can compute times when one object can see another through connections to one or more other objects. These can be single objects or groups of objects. In the STK 12.8 release, chain objects were revamped, and you can now compute optimal strands for a chain. The optimal strand properties allow you to determine the best strands for a computed chain based on a specific metric. When a chain is computed, all possible strands from the start object to the end object through the specified connections are determined, and times of valid access intervals are stored for each strand. Previous metrics in STK were distance, duration, processing delay, and a scalar calculation from Analysis Workbench, and now in STK 13, we've included the data rate capability. Here I have a basic scenario to showcase this capability. First, there are two ground stations, an uplink ground station and a downlink ground station, and there are two constellations of LEO satellites. In blue is the slow constellation with a data rate of 2 megabits per second, and in green is the fast constellation with a data rate of 5 megabits per second. Along with these, there's also a constellation of MEO satellites surrounding the globe, all with a data rate faster than both of the LEO constellations. I'll update these graphics to clean up the scene a little bit. The data rate for each of these objects is specified within its properties. If I open up one of the LEO satellites, we can see underneath Basic, Chain Analysis, we can specify the data rate metric. And here for our slow satellites, there's that 2 megabits per second. This data rate metric is available for all objects that can be in a chain. But note that a transmitter object data rate will always be pulled from the transmitter's definition, not from the chain analysis properties. The chain for this scenario is defined from the uplink ground station to the downlink ground station. From the uplink, you can either connect to the LEO slow constellation or the LEO fast constellation. The LEO slower fast constellations can then connect to the constellation of MEO satellites, which then connect down to the ground station. We can see that defined here. So this chain is from the uplink to the downlink with all of our connections in between. Underneath Basic Strand Analysis, we can see how the optimal strands are defined. And we can see here that we are using the new data rate metric introduced in STK 13. We've also specified to do the maximum strand comparison because we are looking for the optimal strand based on the maximum data rate for the chain. And here's our chain defined in these white lines, and our optimal strand in that chain defined with this green line. For all valid strands at a given sample time, each strand is evaluated for a metric value, in this case data rate, computed by evaluating that metric on each pair of objects in the given strand, and then comparing the values of those links to come up with an overall value for the strand. In the case of the data rate metric, the link value for any pair is the data rate of the first object in the pair, or the transmit node. And then when comparing links over the chain, the minimum data rate value is picked. So in this basic scenario, any chain through the LEO slow constellation will have a strand data rate of 2 megabits per second, whereas any chain through the LEO fast constellation will have a data rate of 5 megabits per second. Since I've specified in this scenario, the LEO constellations have the data rates that are the smallest in the chain. If we go ahead and animate this scenario, we can see that the optimal strand in the chain will go through the LEO slow constellation when the uplink station has no access to the LEO fast constellation. However, as soon as a LEO fast constellation is within access of the ground station, the optimal chain will be through that fast constellation. This is the expected behavior because the maximum data rate should always be through that fast constellation. We even see that it prioritizes the fast constellation even when slower satellites are closer. If I were to change our optimal strand to distance, it would then prioritize whatever satellite is closer regardless of that data rate metric. Right now we are showing all available strands and the optimal strand at a given time in our scenario, but just like any optimal strand metric, we can show multiple top strands at any time. Here we're seeing the best strand in green, the second best strand in yellow, and the third best strand in red. This new capability is a great resource to help users analyze the problem of maximum throughput of a network. Thank you for your time.